chemistryadventure.com.
Okay, hi, this is Screencast 12.11. One of the things chemists like to do with energy is think about what's happening as a substance is being heated or cooled. A complicated factor is that it changes phases a couple of times or even more as it heats up. So here's an example done for water. We have specific heats at those different phases. We know how much energy it takes to melt or boil this substance, and we're going to ask ourselves how many nutritional calories, not joules, but nutritional calories are required to heat a mole of water, 18 grams, from minus 20 to 110 degrees Celsius. Notice that this thing is going to undergo two phase changes when it does. So there's a lot in this calculation. Here we go. As it heats up, it's starting at minus 20, it goes up to 0, and something happens. It's going to melt, and that'll take some energy. Then it'll go from 0 degrees all the way up to 100 degrees before it boils, and that'll take some energy. And finally, it can go above 100 degrees Celsius in the form of steam. To go from minus 20 to 0 degrees Celsius, we can apply Q equals mc delta T, and we know what the mass is, we know what the specific heat is, but make sure you choose ice. And we know that the change in temperature is 20 degrees Celsius, 700 joules. Fine. It's then going to melt. That takes 334 joules per gram, am I right? Let's see. Yeah, 334 joules per gram, 18 grams. Wow, took a lot more energy to melt than it did to get up to the melting temperature. It's going to go all the way from 0 to 100. You'd think that's a large component, but let's find out. It's still 18 grams. The specific heat, we better choose liquid water. And let's see, delta T is the full 100 degrees. Well, it's more than it took to melt, 7,500 joules roughly. And now it's going to boil. Check this one out. This is pretty amazing. To boil this stuff, we're not just getting it to bubble a little, we're going to boil it to dryness, if you will. Let's see, it takes a huge amount of energy to do that, 2,000 joules per gram. We've got 18 grams, massive number compared to the others. Very interesting. And we can even go above 100 degrees Celsius, 18 grams. See, we better choose steam. Be careful there, 2 joules per gram, about the same as the first one we used. And it's only 10 degrees of temperature increase, that's 3,000 joules. Final, add them all up and we got 58,000 joules. Sounds like a lot, but let's convert to nutritional calories. Don't forget there are 4,184 joules in a nutritional calorie. Our units cancel and we find that it takes only 14 nutritional calories to heat 18 grams of water from minus 20 to 110 degrees Celsius.